the beam system is equated to 0, as per that RAV minus W into L plus RB is equal to 0, and we obtain RAV plus RB is equal to W into L. Now third equation, third equilibrium condition, sigma MA or sigma MB is equal to 0. Let us take over here sigma MA is equal to 0. Summation of all the moments of forces acting at point A is equal to 0. So the value of moment because of RAH and RAV is 0. W, this W is the UDL. So W into L is the total load into L by 2, that is the moment created by W, creates a clockwise moment at A. So W into L, load multiplied by perpendicular distance L by 2 plus sign. Now RB creates the anticlockwise moment, therefore RB into L is equal to 0, and we achieve RB as WL by 2. By substituting the value of RB in the equation of this RAV plus RBWL, we can achieve RAV is equal to WL by 2. So using the equilibrium conditions, we will able to find out the support reactions. So support reactions are known with us, and our intention right now is to plot the shear force and bending moment diagram. Let us start with the shear force diagram over here. Given beam is of simply supported beam with UDL is given to us, W kilo Newton per meter. The reactions are WL by 2 and here WL by 2. Length is L. For shear force, we have to find out the variation of shear force. When what is the value of shear force is over here, what is the value of shear force is over here. At each and every point we have to find out the variation of shear force. Now from the previous problem we found out that support reaction itself, the shear force at that particular point. The first concluding remark or the observation that we noted from the first problem. But let us be found out once again over here by taking a section XX, distance x from A. Now you can take section X over here also, because the figures remains unchanged, because only single load is there subjected to W throughout the length of beam. So let us plot over here the free body diagram. Now what is the shear force XX at section XX? Shear force is defined as algebraic sum of the forces, algebraic sum of vertical forces to the left of a section or to the right of a section. Right now we are considering section and it is on the left side. Then section left upward positive sign, WL by 2. Now another load is of the UDL, which is acting downside at this distance is of X. So total load which is acting downward is minus W into X. Now see this formula very carefully. The term X will be over here, means linear variation will be observed while we are plotting shear force diagram for this particular beam. Now let us be found out at various important point. SF at A means where x is equal to 0, VHU is equal to WL by 2, because this term is 0 or nullified, x is equal to 0. So the same conclusion or same observation we found out that reaction, support reaction itself, the shear force at that particular point. Now let us we take x is equal to L by 4. Shear force at that location is WL by 2 minus WL by 4. It is we found out is equal to, what is the answer? It is WL upon 4 plus sign. Do you agree with me or not? Definitely, because if we take list count to a 4, if it is 4, the answers comes to be this one. Now let us take x is equal to L by 2. Shear force at center is equal to WL by 2 minus W into L by 2. Both terms are similar. Answers comes to be 0. If we take x is equal to, if we take x is equal to 3L by 4, SF is equal to WL by 2 minus W into 3L by 4, and this gives me minus WL by 4. And if we take x is equal to L, SF is equal to B, because when x is equal to L, you should visualize, when my x is equal to L, then shear force at B, it must be WL by 2, but see the sign conventions over here, WL by 2 minus W into L, it is minus WL by 2. Why minus sign? Just see over here, section, it's right, it is upward, obviously it is negative sign. So now let us the plot the variation of shear force diagram along the length of the beam. Then this is the simply supported beam with UDL. At all the important points, dotted lines, this is the center point, my baseline. Now shear force at A is plus WL by 2. So at A, WL by 2. At L by 4, it is plus WL by 4, and at this center point it is 0. And visualize this equation, WL by 2 minus WX, inclined straight line is the variation, or even though if you plot this one is WL by 4, and if you are joining all these points, it is inclined straight line. You just see the inclined straight line we achieve over here. If we are going to plot for the next one, next phase after center line, minus WL by 4 at 3L by 4, and for the x is equal to L, it is minus WL by 2. So this value is of WL by 2. Minus means below baseline and joined with the help of straight line. So this is inclined straight line. Be careful, inclined straight line is there, minus, plus, and this variation is straight line, not a curve. All the variation. This is nothing but our shear force diagram. Let us observe over here, variation of shear force diagram, plus sign, over here it is minus sign, and WL by 2, here it is WL by 2. I wish it is now clear to you how to plot the shear force diagram for a beam with UDL. So the two important points that is we observe over here, our observation. First one, as I discussed in the problem number 1, reaction at support of a simply supported beam gives the direct value of the shear force at that particular point. When there is a UDL, the variation of shear force is given by inclined straight line. Recall the previous case. The observation, between 2 point load, if there is no point load, the variation between 2 point load, if there is no load, the variation of shear force is given by horizontal straight line. But here, for a UDL, variation of shear force is given by inclined straight line. Let us plot bending moment diagram. Here, the beam is over here with us. Beam is there with us right now. We have to take a section XX over here, and let us found out, or let us go for the equation. So bending moment at XX is equal to, let us draw the free body diagram for the same. It is there over here. This is our free body diagram. Free body diagram. Bending moment at XX is equal to, first load is WL by 2. WL by 2 into X. This creates a section left clockwise plus sign. Section left clockwise moment. While this UDL creates anti-clockwise, minus W into X is the load into X by 2. This is the basic equation, and this equation in terms of is equal to WL by 2 into X minus WX square by 2. It is X square, and this in terms gives us the parabola for bending moment diagram. See over here, this in terms of only X, multiplication in terms of only X is the inclined straight line. Here the term X square by 2, it is the parabola. Let us found out the value of bending moment at various points. Let X is equal to 0. Bending moment at A is equal to, X is over here, X is over here, my BM is 0. Let us take at X is equal to L by 2. My bending moment at center is equal to WL by 2 into L by 2 minus W by 2 into L by 2 square. And if you simplify this equation, we will obtain WL square by 8 with plus sign. Taking X is equal to L, we found out bending moment at B, at support B. What is the answer? Obviously at the two supports, answer must be 0. So WL by 2 into L minus WL square by 2 It is nothing but 0 because both terms are similar with the negative signs. The answer comes to be 0. Now let us plot bending moment diagram variation of BMD over here. See this figure. This is my baseline, and if we plot 0 at the two supports, here the value ordinate maximum, that is W L square by 2, and if we see this equation over here, it gives the parabola, then it can be plotted. Plus sign. If you want to achieve this exact shape parabola, you can find out the value of ordinate of BMD at x is equal to L by 4. You can take the ordinate at 3L by 4, and by joining these 4 points, 1, 2, 3, 4, 5 points, we give that parabola. This is nothing but the parabola. So parabolic variation is there. This is my bending moment diagram. So let us revise over here, or let us find out the conclusion over here. See the figure over here. When there is a variation, when there is a beam with the UDL, the BMD variation is given by parabola. WL square by 8 is the value for a simply supported beam. So now today in this session we learn about what is shear force, what is bending moment, the sign convention for shear force and bending moment, and we solve the two numericals, very simple numericals, and we try to find out or try to draw the shear force diagram and bending moment diagram. In the next part, next series, we are going ahead with solution of more numericals. Thank you.